All right, so our first session, for those of you who have met me, my name is Steve Wierenga. I am business development here in Canada for Spartek Systems, and we're going to be discussing some of the newer fires or safe fire perforating systems that Spartek has in our catalog and our offerings. Hopefully we'll be able to clarify some of the regulatory changes and some of the documents that we've come along. And there we go. All right, so when we're dealing with perforating in particular and electric detonators, the well sites tend to be conducive to a lot of energized systems. That has only increased in the last several years with the new types of completions, particularly horizontal, where we have simultaneous operations, a lot of well site communications going on, where we used to shut down all the radio systems. That's not even possible anymore for safety concerns. So we tend to leave those on. Transmit towers, RF is popping up everywhere in our world. Up here in Canada, we notice, especially the farther north you go, a lot of the rigs now carry cell boosters on them and some of the light tower systems. So it's one of those things we really have to watch for. So we're going to talk about some of the technologies that can help protect us in those environments. Stray voltage, always an issue, be it electric generators, arc welding, cathodic protection systems, offshore platforms, marine radios, the likes. And then of course, if we're in a high storm risk area or season, we're looking for options where we can perform our operation safely. The documents that we're going to refer to today, there's three of them in particular that are of interest. RP67, so the American Petroleum Institute, RP67 is oil explosive safety. This document's been around for quite some time. However, the newest edition just hit us in October of last year. So in here, we're going to find a lot of information on the new groupings of detonators, which really has brought this webinar to highlight. And then we'll also be referencing the international makers of explosives, the IME Safety Library publications, SLP20 and SLP32. 32 is where we find a lot of our definitions and how we classify different types of detonators. And then Guide 20 is really where we focus in on when we're working through RF potentials on location, and that document will help us walk through how to safely set up our inclusion zones. As far as within these, RP67 specifically is where we're going to find the three different groups of detonators. This is new. This is has not been included in RP67 before. It was a long time in coming, and it's nice to see it finally have some definition. The group 1 is where includes our 50 ohm no fire, 200 milliamp, and significant exclusion zones required for this one. Those are standard detonator that we've been using for years and years. So there's exclusion zones that we have to be aware of. That's per manufacturer, quite often as per regulatory compliance as well. Then the newer groups, group 2, which is a restricted RF inclusion zone, and then group 3, which is no required exclusion zone, and it's an RF safe module. As I mentioned, SLP32s, we're going to quickly dive in and reference the definitions of the high energy electric detonators or HEED detonators. And then we'll continually bounce back and forth to references in SLP20 regarding RF safe transmission, exclusion zones, manufacturer guidelines, how we come up with all that. Okay, so specifically today, as far as the Spartek world is concerned, we're going to talk about two specific technologies, the expendable fire sets. Within here, we find the PX1 and the OM1. These have been around for a bit. You may or may not have been aware that Spartek picked up this product line a little while ago, and we are now the manufacturers of these devices. So we're going to talk about them. And then a little newer to the catalog is the RF safe addressable switch system that we'll go through. That'll be the second portion of and how that complies with the different groupings and how we set that system up for multi-stage gun systems. All right. So we're going to first off, just before we get into the different devices, just a little refresher on the different types of detonators that we encounter in the oil well explosives, and we'll do a quick definition, and then we'll talk about the groups that we see from RP67. So our conventional 50 ohm detonator, been around forever. As per our RP67, and this isn't new, we've always had this. It's against recommended practices to shoot non-resistorized less than 50 ohm detonators in an oil well environment. We haven't shot 1 ohm or less detonators in a very long time. So this type of detonator you'll either find in the group 1, so the traditional exclusion zone, and under special circumstances you will find it in group 2 and possibly in group 3 if there's no primary explosives. So typically a 50 ohm detonator, conventional, will contain a primary explosive. They can be fired at half of an amp at 50 milliseconds. I got corrected on that this morning. Sorry, bond log is my other world, so I talk microseconds a lot. My apologies. 50 milliseconds at 0.3 to 28 volts. No special circuitry is required. Our shooting panels, any RP67 compliant shooting panel will typically set these guys off, but they are sensitive to RF, stray voltage, welding currents, cathodic protection devices, impact. So they require a pretty extensive exclusion zone. The detonator itself is initiated by the bridge wire heating up when we apply current to it, and that heat initiates the primary high explosives. The one pictured here is a lead azide, and then that will continue the explosive train onto the base load and into the perforating device itself. When we're talking HEED, or high energy electric detonating systems, the two most popular that we see is the exploding bridge wire detonator. It contains no primary explosives. It needs a significant amount of energy, so 800 amps to 1,000 amps per millisecond to fire. It does require special circuitry, typically found downhole. These are immune to RF, stray voltage, current, welding currents, and everything, insensitive to impact. So these are typically found in a group 3 type detonating system. And the explosion is initiated by the violent release. So it's a shock wave of when that bridge wire actually pops, as opposed to just heating up. There's a physical impact that we see in this type of detonator. The other not quite as common HE or heat detonator is the exploding foil initiator. Exploding foil initiator actually has more often than not a captain disc in it. The exploding foil, what will happen is same thing. We hit this detonator with a significant amount of energy. That exploding foil actually pops and sends a captain disc across and into the high density H&S. So it's a physical impact that starts this initiation. Again, it's immune to stray voltage and RF currents. Does require specific downhole or fire sets. And because there's no primary explosives, it qualifies as a group 3 type detonator. The other thing that's changed a little bit is igniters have had clearer definitions. So to get them out of the detonator world, an igniter is not an explosive. It is a pyrotechnic initiator. It's designed for setting off the low explosives that we find in our power charges, some time delays, ballistic devices like that. So there's no primary high explosives found in here. They require 0.8 of an amp all fire. Resistance typically 51 ohms or greater. And it's resistant to RF as there's no lead wires, so there's no antennae in these devices. So they fall under their own little special rules. So as I mentioned, RP67, the 3rd edition, came out in October. Of this year, and of last year, and this allowed us to actually the industry got together and updated all this. So in here we'll find the detonator definitions and the groupings thereof. And this is what has changed our world significantly. It still states that a minimum of 50 ohms of resistance per any detonator. All right. Group 1 detonator. And we're going to pause after we finish these just to take some questions. So I see there's some chatter in here. We'll make sure that we get that cleaned up. When we're looking at the group 1 of detonators, they must have the following features. So this detonator group may contain some primary explosives, and more often than not they do. Overall resistance shall be greater than or equal to 50 ohms, as we mentioned. Has a no fire of at least 200 milliamps. And these detonators are sensitive to RF energy on their own. Now they can be married up, usually with some electronics, which we'll talk about when we get to the switches. It may actually bump some of these detonators into a group 2, but without any additional circuitry or anything. These are our standard detonator systems. For inclusion zones, if you do not have regulatory requirements in the area you're working with, you can reference IME-SLP 20 guidelines, and that'll help us determine what the exclusion zones need to be, and work our way through those and set up our safe distances. New to the industry is the group 2 and group 3. So the group 2 detonators, there is some differences between the two. It's a sensitivity, so these ones typically are RF resistant detonators and higher energy required. So the group 2 may contain some primary explosives, so there may or may not be a primary in there. Detonators shall have a no fire voltage of at least 25 volts AC and DC. And then the RF sensitivity of each single transmitter must be evaluated in SLP 20. So they will require some documentation and work depending on how those devices are used and what the configurations are. One of the conditions that's important for these ones is that there cannot be any single point of failure that results in unintended detonation. So environmental limits such as temperature, pressure, impact, all of those fall into here. Group 3 detonator is our immune system. So these ones typically, unless regulatory compliance overwrites it, you will typically not require a exclusion zone. These detonators will not contain any primary explosives. So the EBWs, EFIs definitely fit into this group. These detonators shall have a no fire current of at least 120 volts AC DC. And they must be immune to RF energy emitted by each transmitter or frequency and output defined by SLP 20. This includes marine transmitters, which tend to be a lot higher power rating than land systems. Detonators of this group should be designed again for any single point failure. So temperature, impact, pressure should not be the initiation or cannot be the initiation device. When we get into the PX1 and OM fire sets, this is what we typically pair up with these, or we can use group 3 detonator. We'll have a no exclusion zone on them. The switches may fall into there as well. All right, so that was a really quick brief review of the PX1s, or sorry, the detonating type systems that are out there. So I'm going to take a quick look at our chat. Looks like we've got everything kind of lined up. Cool. I think we've moved Josh over to attendees, so we're good there. Josh, somehow you snuck in there as a panelist, but we moved you over. All right, so we've talked about the types of detonators that we have and the groupings that they fall into. So specifically with the Spartex systems, how do we achieve these increased levels of safety? So the first one is the fire sets. Again, traditionally a PX1 or the OM1s. Spartech is now the manufacturer of these devices. I picked up this product line a bit ago. These allow us to, so what these packages are downhole initiation devices that will fire the EBWs or the EFIs, so group 3 style detonator. They are immune to stray voltage. They, what the cartridge has is a capacitant high voltage safety circuit supply, and then the output capacitor is a trigger mechanism. The module itself is what the PX1 is, and then they're compatible with various different detonating systems out there, so there are quite a few available for EBWs and EFIs. When we connect these devices into a gun system, they can either be combined with switch systems or they can be standalone, so a single fire initiation. You'll have the output wires come in. You'll have a ground and then 2 input wires that run through the gun, and then our detonator is connected directly to the leads. A couple different versions, either spring-loaded if they're the older legacy ones, or they'll be hardwired right in to increase the reliability of them. They do require a specialized chamber that can either be, if you're going to dispose of them, they'll go right into a arming chamber, or they may be segregated into an atmospheric chamber for those systems. When we fire the EB or the PX1s, in particular, this is the output of the PX1. The OM1 is similar. What it allows us to do is get within the pulse range required for EBWs and for EFIs. So you can see there, we got a quick chart on what the PX1 output is, and then the yellow graph, or the yellow line on the graph, indicates what the required pulse to fire the EBW or the EFI is. And you can see they fit well within that pulse. As far as technical specifications, the PX1 is it's good up to 225 degrees centigrade. It has a power input of 200 to 230 volts DC at anywhere from 150 to 250 milliamps. And then the output is significant, so 5,000 volts plus or minus, and that's what gives the exploding bridge wire the pop and the energy it needs to fire. So I am, as I mentioned, I am from Canada, so that works out to 435 degrees F for those of you tuning in from the US. I do speak both. I just tend to default to imperial, so sorry for that. If you're looking for the imperial numbers, please just drop us a line and we'll make sure we convert that real quick. The OM1 fire set, very similar to the PX1, except that it is specifically designed to work with electronic trigger systems. So the Spartech electronic trigger, the QCT, is a battery operated system that will also hook to this type of detonation system. So we're able to use the EFIs and EBWs with the electronic trigger systems. We're going to, actually our next webinar is actually on those systems. So if you'd like to know more about the electronic switches, by all means, stay tuned. You should see the invites coming out here in a couple of weeks. As far as safety aspects of the fire sets, special equipment required to shoot them, no, not really. They pretty much any shooting panel, unless it's a little bit old, does not have clean DC power output, which most of the panels now do. They will be able to fire the PX1 module, and then of course the trigger requires a trigger, or the OM1 requires a trigger to fire it. The higher the temperature, the fussier the switches tend to be on the power. So as long as they're clean, again, our business development managers for your region would be happy to work with you to make sure that your panels are compliant, or what we need to do to clean them up for you. Do you need to pretest the PX1s. They come pre-tested. You can check them, but it's not recommended. We do all that testing before shipment after manufacture, and we recommend that they only be used once. The minimum surface applied power necessary to charge, so if you're checking your shooting panel, if your specifications allow for 1 amp at 250 volts DC, that's the recommended output for your firing panel that will fire these devices. And then as far as SLP 20 and 32 are required, where we test these devices third party. The testing was done by Orion International Technologies, and all that information is available to show the testing for the different RF exclusion zones, as well as the temperature and impact resistance. All right, that brings us quick and dirty. We're trying to value everybody's time here, so we are going through this fairly quick. This presentation, our plan is to share it after the fact. So if you're looking for a copy of this, by all means, let us know, and we'll be happy to get that sent out when the videos are ready. Or you can contact your business development manager that you're used to talking to, and we'll make sure that we help you out with any documentation you need. Now, with the next system we're going to look at is the Safe Addressable Switch. And the Safe Addressable Switch system, fairly new to our catalog, been a big change in the particularly the North American market with horizontal multi-stage pump down systems. So the addressable safe system that we market is compatible with the Warrior logging system. It does require a shooting panel that has been upgraded for multi-stage devices, and there's a couple options available for that. So again, this is something that we can help you out with. If you have existing components, we'll be able to check that for you, let you know if it's already compliant or if it needs an upgrade or if there's other options available. Then the switch itself, these are individual per gun. And then the components that we apply with them, there's an option of the RF Safe Tester, which can either be in a panel module or in a Pelican case portable module. Both of those can be plugged in the inline system, as well as being used to test gun systems not hooked up to the line. And then just so that we can help everybody learn how to use these things, because it does require some training, there is a simulator trainer that is available as well that's portable there. Now, as far as what the switches are tested to, depending on the type of detonator that you are using within the system, we can either have these switches fall into a group 2 or group 3 category. So again, it depends on what detonators we use and how we wire them up. The third-party testing was done by Franklin Applied Physics in the US, and it's been validated for the electrical specifications, and the no single point failure has been all tested. And then as well as the hardware has been tested for the RF transmitter and mobile radio transmitter specifications. And then there was also some independent third-party testing for the temperature rating to make sure that they won't fire at temperature. Again, this documentation is available if you require it for regulatory compliance or to work through it with the fields that you're involved in. The switches are typically run in tandem with other guns, so you'll have multiple gun systems and or plugs and release systems. So the switches themselves can be programmed to either detonators or to plugs or to ballistic releases. The Group 2 will use a 50 ohm resistorized detonator with primary explosives. So once we have that, depending on the, we need to manage the lead wires for antenna for the Group 2, or sorry, IME-SLP 20 exclusion calculations. And then if you're using something like a PX1 with an EBW or EFI, then you fall into the group 3 category, no exclusion zones. Depending on the regulatory compliance where you're operating, so the jurisdictions, RF safe capabilities may allow you to actually do advanced arming of the gun systems. This will help improve operational efficiencies. Again, this is as long as your local regulatory compliance does allow it. Now, certain jurisdictions do not apply that practice, but if you do operate in those areas, then it's a great system for advanced arming, everything except for the last gun, of course. The switches themselves have a two-way communication, so real-time diagnostics. So the system is talking to the switches and the switches are talking back, so we can watch those switches as we need. And then make sure that we have that communication with the surface and downhole systems. So you can check everything before you get to bottom, and you can check everything as you go to bottom. The system will actually support over 100 switches, so you know, in actual fact, there's really not much of a limit on here. 100 switches is by far way more than we would typically need in a gun system. You're going to run out of crane or pressure control before you typically run out of ability to put in multiple switches. And then the select firing has a confirmation in it as well. So when it's armed, it will let us know that it's armed and it's communicating, and then it'll let us know that it's received the fire communication. Come on, there we go. As far as functional testing of these switches, they are done during manufacture. There's 3 levels of testing. So there's a 3D optical of each switch is done before it is sent for testing. Before it's potted, it has a full functionality test, and then after potting has another functionality test just to make sure everything stays good. Again, that documentation is available as required. If you're looking for it for specific environments, we can definitely work with you to make sure that it fits. Okay. As far as multi-levels of safety, we do use the Unifier software. As I mentioned, it uses the Warrior module, and it is specifically the Unifier module of the Warrior logging system. This module allows for communication on power up, so it checks every switch. It does if there is a failure, it will put that switch to a shunt. And then the internal program memory, there is a black box on every switch that also records. So in the event that you do have a switch not fire and you bring it back to surface, if that switch is intact, we're able to double check to see if what we saw at surface is what it saw downhole. And then it verifies the internal voltages. The encryption is used. There is an encryption code for select commands, so you can set it to arm and fire. And there is timeouts for those arms and fires, so you can safely bring these devices back to surface if required. The actuator is shunted to a 400 ohm resistor across the detonators, and it has a 75 volt lockout on the detonation circuit after a fire command, so keeps it into a safe mode. Again, this has all been tested as per RP67 latest draft, so this is available as we need. Now, as far as what you need for line and system capabilities, as I mentioned, it take over 100 switches, can be combined. That's probably far more than the need for any standard system. But it also is compatible and has been tested for over 30,000 feet of line. That's 9,000 meters of conductor and jacketed cable. So it's been tested on. I mentioned the black box recorder that you find in that switch. So in the event that we have a failure, all the commands, the actual time, the maximum temperature, so switches have temperature monitors in them, so they watch the temperature, and then all switched records are kept inside the detonator as well as its surface. The unifier interface that we find in the Warrior system actually does auto-create an event log, and in there you will find which switches were programmed for either a release, for a detonation, or for an igniter, and that audit trail can be downloaded and tracked for stats and diagnostics. And then the other aspect of the interface is the fact that it is designed for the perforating engineer in the field. So nice large fonts, color codes for in-depth windows, big visual indicators for switches on and armed and firing commands, as well as keeping track in the gun system of what's been fired and what hasn't, what stage you're on. And then if you do have a failure in one of the modules, it allows you to skip a gun and move to the next module. And there we can see that not only are we large fonts, but it also has a window where the supervisor engineer can actually watch the current and the energy levels going down the line. So they can keep an eye if there's a power issue, then it's very visual and very quick to diagnose. As far as surface hardware, it's obviously the logging panel is required. As I mentioned, there's a couple options for shooting panels. They need to be modified to handle the multi-stage systems. That connects directly to the slip rings on the drum down the line, and then to each individual switch inside the gun system itself. And you'll find that the downhole system is set up into a switch so that you can apply logging and or shooting voltage as required and as the commands are sent. Hey, we talked a little bit about the gun communicator at the beginning. There are two versions of this. There is the portable Pelican case that allows you to check gun systems independently of the wireline, or the panel mounted communicator that goes in line in between the shooting panel and the drum, and that allows you to do real-time tests with the line, and as you go into the wellbore you can do communication checks. It's a simple color-coded 2-button usage, so allows everybody to, the guys to check it easily. It runs off standard AA alkali batteries, so nice and easy. You're not looking for anything fancy. There's a wireless link remote control function in here that communicates with an app with a smartphone. We're going to talk about that in a couple minutes here. A very nice feature that gives you a lot more diagnostic power and reporting features. There is a analog gauge for just a quick voltage verification. And then the system itself is a USB port in line and allows us to field upgrades as required. So if there's a change to firmware, or we added a new feature, or given it a new set of detonators that it can talk to, then you don't have to send that panel back. It's just a quick upgrade using the USB port. So very functional. So where do we put that tester in place? As I mentioned, it goes from the logging panel to the shooting panel, and then we'll put that right in line. It can either be plugged in if you got the Pelican case version, or it'll be hardwired in if it's a rack mounted panel. I mentioned the app, so most of our engineers are of that age where they'll find this very user-friendly, and it's well within their realm of daily living. So pull out your smartphone. It's a Wi-Fi connection, very short range, and allows communications with the testing panels. In here you can build your trigger inventories. You can upload or download those inventories. It allows you to program your switches. So either it can detonate detonators, or you can initiate the initiators for setting tools, and then set it up for detonator triggers for release as well. And it can be done in the field. So if you get out there and somebody's pre-programmed all your switches to initiators as opposed to detonators, you're able to easily change those back. It's just a quick connection and a reprogram through the app. So the app is downloadable through both the Android and the ISO app system. So again, very handy. It's not, you don't have to send the phone away. It's just a quick dial in and away you go. The last component that we also mentioned earlier is the gun simulator and trainer. So as per RP67, our engineers need to be trained in these systems. So there's a simulated a cable simulator built in, and it allows the quick connect for your switches. So you can either you can daisy chain these in. So if you need more, you want to train, and it's very portable. It also works off other switch systems, so it's not just the Spartex system. This tester is compatible with other systems as well and can be used for training. All right, as I said, short and sweet. We've hopefully we've captured a lot of this information for you. Just a quick rehash of the switching. As far as safety is concerned, third-party testing has been completed for all high voltage, RF immunity, and ESD safety. The ARM fire command encrypted with different keys, and there's a 75-volt shutout on the firing circuit with everything going to shunted actuator. As far as the functionality of these switches, very fast. They are 0.2 of a second per switch, so it allows for on-the-fly shooting. There are temperature sensors built in, and there's an event logging of each switch in the Warrior system. So you get a log and an inventory of everything you've done, complete with the current measurement per switch comes up in those reports. As far as reliability, they are tested twice during manufacture, as well as the 3D optical. There's no operator communication, so when they are communicating with the switches, the panel does it all automatically, so it adjusts the levels of communication. So no human interface, so nobody can preset your panel to the wrong communication, and there you are stuck in the field. And then as far as reliability, we've had over 800,000 of these switches run so far in Canada and the US, so the reliability is extremely good, and engineered and manufactured in multiple locations, so we can get these systems out there. All right, that kind of brings an end to our systems. I see we have a question. Presumably we sell all the hardware. Detonators, what we'll do with detonators, because of the globalness of the systems, we'll work with you to get hooked up with a local provider. So we have those contacts, and depending where you are at, will depend on which switch is probably best for your market. Again, we brings us to the end here. We thank you for participating in this webinar. We're going to stay on. We're going to turn off the recording here in a bit, and then we'll just leave the chat window open. If you like to stay on with us for a little bit, we'll answer any questions that we can, or put it offside where we can contact you directly if they get to that point. Our next webinars in a few weeks. We'll be doing a webinar on electronic firing systems, the QCT module. We're also going to be talking about our fast gauge system for putting on gun systems, so you can record the events. If you have any questions at all, please, we are a global company, so we have business markets all over the place. If you're not sure who to reach out to, we have in your follow-up email, we'll send some contact emails for our business development managers. We'd be happy to get in contact with you and work you through any of this product line or any of our other product lines. So again, thank you for joining us for this webinar, and we'll turn the floor over to the chat room.